Very good morning. Now I'm going to discuss about IP address in networking concept. Okay. So already we know that what is network. Network is collection of nodes or interconnection of nodes, which is used to share the information, or we can share any data from one device into another device. That's why we go for what networking concept. How data can be shared with help of what IP only, right? So IP is internet protocol. It is connectionless protocol, right? Uh, we can able to share the data from one device into another device, right? Here the IP can be classified into different types. That is classful address, even classless address. There are two versions of IP. Even we have IP version 4, then IP version 6. Okay, IP version 4 is nothing but we have 32-bit address, right? So here there are 4 bytes we have, right? The entire IP can be considered as 4 byte, byte 1, byte 2, byte 3. This is byte 1, byte 2, byte 3, byte 4. Okay, each byte we have 8-bit data. Okay, 8-bit data. 8-bit data. Okay, 8-bit data. Totally we have 32-bit address. We have 32-bit address. Okay, because 4 is nothing but 4-byte data. 4 into 8 equal to 32-bit address. 32-bit, by using 32-bit address only, we are going to store all the data while using IP version 4, right? So in IP version 4, we have this can be classified into 5 classes. That is class A, okay, class B, class C, and so on. First, we will discuss about class A, right? So the given IP version 4. So 4 byte data. Out of 4 byte data, the first 1 byte will be allocated for net ID. The remaining 3 will be allocated for host ID. Okay, because network is nothing but what collection of node. Okay, so internet is nothing but what interconnection of different kind of network. Each and every network we have n number of hosts. All the hosts will be connected to one network. Like that we have the structure. From this only we can able to share the data from one network into another network with help of what some IP address, right? So here class A, the first network we have, the first 1 byte will be assigned for net ID, the remaining 3 byte will be considered as host ID. So out of this 1 byte, the first 1 bit can be represented as 0, right? Because the network address can be represented in two ways. One is dotted decimal notation. Another will be binary notation, right? So what do you mean by dotted decimal notation? Say for example, the given IP is 196.10.11.5. Okay, this is kind of IP. It can be represented by dotted decimal notation because we have 4 byte, byte 1, byte 2, byte 3, byte 4. Okay, so we are going to differentiate from 1 byte into another byte. We are using dot operator, right? So 4 byte, this is IP version 4. So dotted decimal notation, right? The same thing can be, we can write in the form of even binary, right? So the combination of 0, 0, 0, 1, 0 and so on. So here 8 byte, then followed by 8 bit, 1, 0, 1, 0. The rest of the bit will be 0 here, 11, something like that you can able to write. But the user, generally we can able to remember dotted decimal notation somewhat easier than compared with what binary notation, right? So now you are going to identify from the given IP whether it is valid IP or not. Even we can able to identify it because here totally we have what out of one byte, the first bit can be used to identify the class A. The remaining 7 bit, that is 2 to the power 7 equal to 128. Okay, 128 from 0 to 127. So any IP within the range from 0 to 127, it is comes under what class A? Comes under what class A? Already we know that each byte we have consists of what? 8-bit data. Okay. So 2 to the power 8 equal to what? 2 to the power 8 equal to 256. How we can range 256 here? 0 to 255. Okay. Any IP, the ranges from where? 0 to 255. Say for example, here consider 196.10.11.5, whether it is valid IP or not. Yes, valid. Why? So each and every what bytes we have the range from 0 to 250. Sometimes they are given 256 point, okay, 10.10.5. Assume that whether it is valid one. No. Why? This is out of range. Okay. Any IP within the range from where? 0 to 255 only, right? So how to identify whether any organization they are using class A, class B, class C in order to provide the connectivity among n number of users, right? The same class A, assume that consider class A. Here the first one byte will be assigned for network ID. Okay. The combination of network and the host ID is generally called as what? Some classes here. Now the first bit will be here 0, the remaining 7. 2 to the power 7 equal to what? 128. So any IP from 0 to 127, this is the range for what? Class A, right? For example, here 196.10.11.5, this is kind of class A? No, because this is out of range for 0 to 127. Okay, this is, it may be class B or class C. We'll see later. Okay, then what? The remaining 3 byte will be assigned for what? Host ID. By default, 3 into 8. Okay, 24 bits. Okay, so 2 to the power 24 bits can be considered for host ID. Okay, how many hosts we have in this class A? 2 to the power 24. 2 to the power 10 equal to what? 1024 into 1024 hosts we can able to connect for each and every network. But how many network we can able to build it by using class A means here 128 networks we can able to construct it, right? By using single network we can connect this much host here. Okay, so based on the top level organization, the organization may have n number of employees. Okay, huge number of employee. In this case the organization will go for what? Class A. Okay, so class A, this is called class A. The next will be class B. Now okay, the range for class A is 0 to 127. Okay. Now consider class B. Again you are going to consider 4 byte data. So byte 1, byte 2, byte 3. This is byte 1, byte 2, byte 3, byte 4. Okay. First 2 byte will be allocated for network ID. Okay. So first 2 byte will be allocated for network ID. The remaining 2 for what? Host ID. Okay, the remaining 2 bytes will be allocated for host ID. So out of this 2 byte, already we know that the first out of 8 bit, the first bit 0 means it is class A. So it is what? Class B. Here the first bit should be 0, the second bit should be 1. First bit will be 1, second bit will be 0. This is an example of what? Class B in the representation of what? Binary. Okay. So out of 8 bit, first 2 bit 10 means it is comes under class B. The remaining we have what? 6 bit. Okay. So 2 to the power 6 equal to what? 64. Right? 64. Already we know that already 128. Okay. 128. Here 64. Totally we have what? 2, 0 to, this is 0 to 191. Already for class A, we have the range 0 to 127. So that class B, the range from 128 to 191. Okay. But how many network we can able to construct it with the help of class B? Okay. So after neglecting this 2 bit, remaining here 6 plus 8 equal to what? 14. So 2 to the power 14, this is what? The rest of the bit which is available for the network ID. 2 to the power 14, 2 to the power 14 networks we can able to construct it. By using single network, how many hosts we can able to connect it? Here totally 2 bytes will be allocated for host ID, right? So 2 into 8 equal to what? 16. So 2 to the power 16 host we can able to connect for each network in class B. Okay, this is the way of calculation. Okay, how many network we can able to build it with the help of what? Class A or class B or class C or even class D. By using single network, how many hosts we have? Because the interconnection of host is generally called as one network, right? Like that we have n number of network. Each and every network we have what? Number of hosts. So this is the combination for each and every network. Always we are going to consider here. So this is class B, right? Suppose we have equal number of network. For each network we have the range of hosts is 2 to the power 16. We go for this kind of class, right? This is class B. Okay, say for example the given IP is assume that 188.10.5.10. Assume that. Identify the given IP as which class. Say for example this is question. How to identify? From the first byte itself. Okay, from the first byte itself easily we can identify this is class A or class B. So whenever the range is from 0 to 127, definitely it is comes under what? Class A. Okay, from 128 to till 191 comes under what? Class B. But 188 is what? Lies between where? 128 to 191. So that it is what? Class B. Is it clear? So in this way only you should identify from the given IP whether it is class A or class B, right? So the next is what? Class C. Now class B is 128 to 191. Okay, this is the range of IP address, right? So next one is class C. Okay, consider class C. Again we have 4 byte data, byte 1, byte 2, byte 3. Okay, so first 3 byte will be allocated for network ID. The last 1 byte will be allocated for host ID. Okay, out of 4 bytes, the first 3 byte will be allocated for network ID. The last 1 byte will be allocated for host ID. Already 0 represents class A, 10 represents class B, 110 can represent class C. Right? The first 3 bit, whenever we have 110, it is considered as what? Class C. The remaining bits in first byte will be what? Here 5 plus 8 plus 8 16. Okay, totally 21. Okay, totally 21. So 2 to the power 21 network we can able to construct it while using what? Class C. Okay, while using what? Class C, right? The each network, how many hosts we can able to maximum connect means each network 2 to the power how many bits in host ID? Only 1 byte will be assigned for host ID. So 1 byte is nothing but 8 bit data. So 2 to the power 8 equal to what? 256. So maximum we can able to connect each network 256 hosts in class C, right? Now, so what is the range for class C means here each byte we have 8 bit data. Out of 8 bit 110 which is used to identify the class in the form of what? Binary representation. Remaining 5 bits we have 2 to the power 5 equal to what? 32. Okay, already we have what? 0 to 190. It is called as 192 plus 32, 4 to 24. For class C is, the range for class C is already till 199 will be assigned for class B. The next will be here what? 192 to till 223. 223 is the range of any IP for class C is from 192 to 223. Okay. So this is what? Class C. For each network, we can able to connect maximum of what? 256. Okay, because 1 byte will be assigned for host ID. So 2 to the power 8 equal to 256. That much host we can able to connect for each network. So while considering class C, we have more number of huge number of network for each organization. By using single network, we can connect 258. Okay, from 0 to 255, sorry, 256, 0 to 255, right? Mm. Now, so same way, suppose the given IP is, it may be 200, okay, point 5.8.101. Assume that whether it is valid IP or not. Yes, valid IP, because each and every decimal value within the range from 0 to 255, right? Other than that, again you should identify from the first byte, you should identify whether it is what, class A, class B, class C. This is 200. Lies between what? Whether it is 0 to 127? No. 128 to 191? No. From 180 to 200? Yes. So the given IP is what? Class C. Okay. In this way only you should identify whether it is comes under what? Class A, class B, class C. Okay. The next one is what? Class D. Class D mainly used for what? Multicasting purpose. Here there is no split up for the given 4 byte data. Okay. So anyway, we have 4 byte data. Whenever the first 4 bit 1110, okay, 1110, it is used to identify class D. Okay, first 4 bit. The rest of the 4 bit will be what? 2 to the power 4. 2 to the power 4 equal to what? 16, right? 16. Already 224 plus 16, that is 0, here 4, 240. Okay. So already what? From 0 to 239. Already 223 till 223 will be assigned for class C. Now class D IP addresses, okay, from 224 to till 239, right? Class E by default 242 till 255, right? From 0, okay, start with 0, end with what? 255. Already we know that each byte we have only 8 bit data, okay. So 2 to the power 8 equal to what? 256. How we can range this? 0 to 255, okay. 0 to 255. Any IP ranges from 0 to 255. This is valid IP only. So anyway, the entire IP from 0 to 255 can be split into what? Class A we have some range, class B we have some range, class C we have some range, class D also some range, even class E also, because this class E mainly used for feature reference, right? This is mainly used for multicasting. Class D mainly used for multicasting. This is used for what? Feature reference. So generally, most of the organization, I think they are using class B. Okay. So the top level organization, they can use, they may use class A. Okay. Like that, they can able to what? Use it, right? So now, just we are identifying the range, right? Class A, class B, class C, class D, class A. But some of the organization, we have minimum number of employee. In this case, whether it is classful address is useful or not. So it may not suitable for what? Small organization, right? In this case, we go for what? Classless IP address. But here, generally we have, say, for example, 196.10.11.18. Assume that, okay. How to identify the network address for the given IP, okay? Because the combination of network and IP is generally called as what? IP address is nothing but collection of network as well as host ID, right? So you should identify whether it is class A, class B, class C, class C, class D. So 196, it comes under what? Class A 0 to 127, class B, class A 0 to 127, class B 128 to 191, class C 192 to 223, okay, class D 224 to 239, okay, class E 240 to 255, right? Already we know that, right? 0 to 255, total number of value will be 256, right? This is comes under what? Class C. While considering class C, how many byte will be allocated for net ID? So considering class C, so 1, 2, 3. First 3 byte will be allocated for network ID. The last 1 byte will be allocated for host ID, right? So here, so whenever you are going to calculate the network address, I want to calculate network address here. The host ID value can be replaced by 0. Otherwise, we go for what? Masking technique, right? In order to fetch the network address. So here what happened, the host ID simply replaced by 0, otherwise it passes through some masking technique. Again you are going to retrieve the original network address here. 196, 3 byte will be what? This one, because 3 byte is nothing but what here, 255.255.255, okay, point 0. This is the default masking value for class C, okay, default masking value for class C. So once we are going to, okay, take the corresponding binary for 196, 10, 11, 18 as well as 255, 255, 255, 0, you are going to apply normal binary and operation. You are going to get what? 196.10.11.0. The implied meaning of this is what? You are going to get the IP address. The host ID value can be replaced by what? 0. Then only you are going to get the actual network address, right? Suppose I will send the packet. I am sending some information from one node into another node. First, you should identify the network address, okay? After identifying the network address only, I can able to find the host. Even before finding the host, I can able to identify the subnet. Suppose the network is subnetted, we can identify the subnet. Then only we can able to route the packet to the subnet. The subnet can find the host. Then only it can forward to the corresponding host also. In this way only the data can be communicated from where? One host into another host, right? This is one way. This is kind of class C. Consider class A. So class A generally what? For example, 0 to 127. Already I said 120.111.100. For example, 10. I've seen that. Whether it is class A, class B, class C, it is class A. How? From the first byte data. So within the range from 0 to 127. Okay. So what is the default mask for class A? Because only out of 4 byte, the first 1 byte will be allocated for net ID. So remaining 3 will be host ID. The network ID is always we are going to consider as 255. The rest of the host ID value will be considered as 000. Then you should apply masking technique here. So you are going to get what? 120.0.0.0. This is called network address for the given IP for what? Class K. Okay, this is the actual network address for class A. Because easily we can able to identify the range for class A is what? 0 to 127. Yes, by naturally 120 is lies between here to here. Here out of while considering class A, there are 4 bytes already, we know that. Okay, first 1 byte will be allocated for network address, the remaining 3 for host address, right? Easily we can able to identify it. The host ID value simply replaced by 0, otherwise you can use masking, right? There are two ways to fetch the network address here. So yes, 120.0.0, right? So after finding the network 120, then I can able to forward the data to the corresponding host easily. In this way only data can be communicated. Consider class B. Consider class B. The range is, for example, 190.18.10.5. I've seen that. Okay, this is given IP. Identify whether it is class A, class B, class C. So how to identify the class? From the first byte, right? 190. This is range between what? 128 to 191. By default, it is class B. For consider class B, every time you should remember, out of 4 bytes, the first 2 byte will be what? Network address. The remaining 2 will be what? Host address, right? Host ID, right? So here what happened? The first 2 byte will be network address, means host ID part should be 0 by default, right? 255.255 default masking value for class B, 0.0. Now you should apply normal binary AND operation. Then you are going to get what? 190.18.0.0. This is network address for the given IP. Okay, this is the network address for the given IP. So once we are finding the network, easily we can find the host ID also, right? So like that we can able to identify the network address as well as what? Host ID value. Okay, this is the overall introduction about what? Classful address. Okay, there are different kind of classes we have. Then I consider IP, we have, there are two version, IP version 4, IP version 6. So 4 is nothing but 4 byte data we are using, totally 32-bit information, right? So this can be classified into class A, class B, class C, class D, class E. How we can able to identify network as well as host. What is the range for each and every classes we discussed so far, right? So this is a very simple concept. Easily everyone you can remember how to calculate the IP address, whether it is valid one or not. Everything we can able to identify simply once we know the concept very well about IP. Thank you.